Welcome to Education Express, my dear friends. Let us do a few selected questions from Indices chapter 7C exercise. Though we have done this chapter entirely on the Zoom class, but few selected questions which will help you for future reference. So, the question is 2 raised to x equals to 4 raised to y equals to 8 raised to z. Now this information is given to us and even this information is given to us. What we have to find? We have to find the value of x as x is how much. Can I say this is 2, even this can be made a base of 2, even this can be made as a base of 2. That means 2 raised to x equals to 4 raised to y. So 2 raised to x equals to 2 raised to 2y. In short, bases are same. Therefore, reason to smile. We are comfortable x equals to 2y. So in place of x, we can always put x equals to 2y. At the same time, my dear friends, 2 raised to x is also equals to 8 raised to z. Taking the base as same, we can say 2 raised to 3z. So my dear friends, bases are same. The reason to smile, x is nothing but 3z. So we found the value of x in terms of y, or you can say y is found in terms of x. Z is also found in terms of x. So all the values are available with us. Since this is available, 1 upon 2x plus 1 upon 4y plus 1 upon 8z equals to 4. In place of x, we will keep x only. In place of y, since we know y is x upon 2, so we can simply say 4 into x upon 2 plus 1 upon 8 z is x upon 3. So we can simply say x upon 3 is equal to 4. What do we get? 1 upon 2x plus 1 upon 2x plus 3 upon 8x equals to 4. If you take the LCM, my dear friends, LCM is going to be 8x. So in the denominator we have 8x. This would be 4 plus 4 plus 3 equals to 4. 3 plus 3, 8 plus 3, 11. 11 equals to 32x. So my dear friends, x equals to 11 upon 32. It was a very simple, precise question. Not a problem at all. What I did is 2 raised to x is equal to 4 raised to y. We found out the value of y in terms of x. Same way 2 raised to x is 8 raised to z. So find out the value of z in terms of x. This equation was given to us in terms of x, y and z. X remained as it is. In place of y, we substituted x upon 2. And in place of z, we substituted x upon 3. That's how the entire equation got converted into linear equation. We solved a very simple linear equation to obtain the solution. Look at the next question, which seems to be more easier than the one we did right now. It's given that 3 raised to 4x, 3 raised to 4x is equals to 81. As we know, 3 base can be made. 3 raised to 4. 4. Who is waiting outside? Minus 1. On comparison, can I say 4x equals to minus 4? Therefore, x equals to minus 1. It's very simple. What about this? So 10 raised to 1 upon y is equal to 0.001 can be written as 1 upon 1000. As we know, 10 raised to 1 upon y can be written as 1 upon 10 raised to 3 is equal to, guys, if you check the question in the textbook, it is 0.0001. So it is 0.0001. So this has to be 1 upon 10,000. So accordingly, this will change to 4 because it is given 0.0001. Alright. So 10 raised to 1 upon y, rest all remaining the same, is 1 upon 10 raised to 4. Now what can be done, my dear friends, is that this is 10. We can make this as a base of 10. So how it will work out? So 10, 1 upon y will be equal to, if you are writing this as 10, this is going to become negative because you have reciprocated this. Now 1 upon y equals to minus 4. So if you reciprocate on this side, 1 upon y will become y. So this will become minus 1 upon 4. So We got the value of x and we got the value of y. So that was the most important part, to obtain the value of x and y. And since both the values are obtained, now you merely have to substitute in this, because this is what exactly we have to find. 2 raised to minus x multiplied by 16 raised to y. 2 raised to minus x. What is the value of x? Minus 1. Minus into minus 1 multiplied by 16. 16. Y. What is the value of y? Minus 1 upon 4. So my dear friends, this can be 1. This can be written as 2 raised to 4 multiplied by minus 1 upon 4. 4 cancels. 2 raised to 1 multiplied by 2 raised to minus 1. That's 2 into 1 upon 2. That will give you 1 as your answer. So guys, I hope you have enjoyed this solution. Quite fascinating, and I'm sure you will like this chapter as well. Let's move on to the next question. Let's move on to question number 12. The value of m is given to you, cube root of 15, which would be 15 raised to 1/3. N equals to cube root of 14, which means 14 raised to 1/3. I have to find the value of this. Seems little ugly, but trust me, it's very simple, guys. First thing is you take the LCM. How? Supposing you have 3 minus half. How do you take LCM? So 3 into 2. 6 minus 1, the whole upon 2. Same way. M minus n multiplied by n square plus n square plus mn. Same thing I have written, but square. So I've just arranged it properly. Minus 1 upon m square plus n square plus mn. So guys, simple LCM. If you recognize, this is the formula for identity of, if you go to C, we have an identity of m cube minus n cube. What is the identity for a cube minus b cube? Same, m cube minus n cube would be m minus n, m square plus n square plus mn. So this identity seems to be fitting into this perfectly. So this is nothing but m cube minus n cube. My dear friends, mathematics is always a consolidation. It is always to be studied comprehensively. It is not a, you can say, a fragmentation. In the sense that while doing indices, we are also using identities that we have done part of it in expansion chapter and part of it in factorization. So all getting converged at one point of time upon m square plus n square plus mn. My dear friends, the value of m is available with us. Why don't we substitute the value over here? If you substitute m is 15 1/3. And who is waiting outside? Sir, cube. Minus n is 14 1/3. Who is waiting outside? Sir, 3. Minus 1. Of course, you will be tempted to substitute the value of m over here also, but my dear friends, keep little patience. Do not substitute, or else you will be simply wasting some of your time. I substituted merely because this 3 will get cancelled, so my working will become little more simple. So 15 1/3 into 3 minus 14 1/3 into 3 minus 1 the whole upon m square plus n square plus mn. Absolutely perfect. So my dear friends, 15, if you check 15 minus 14 minus 1 upon n square plus mn. 15 minus 14, 1, 1 minus 1, 0. And you all know the universal law that 0 upon anything is going to be 0. That's how, by solving these questions, you all can put the impression of hero. Very simple question, my dear friends. Let's move on to the next question. That too looks so simple to me. You only have to focus on the properties that we have done. If you are well versed with the properties of indices, you will certainly find the solutions very simple and easy to do it. Look at this now. What we can do is convert the complexity into the simple part. 2 raised to n, it is in the simplest form. Whereas 6 can be written as 3 2s are. Now you can say that you have broken it. into the simpler one. 10 can be written as 5 2s are, whereas m raised to n remains the same. 15 can be written as 3 into 5, and that is m plus n minus 2. So we have just broken the numbers into the prime numbers. What about 4? So 4 can be written as 2 raised to 2. And who is waiting out? M. 3 2m, that means 3 2m plus n. Let it be as it is, whatever it is. And 25 can be written as 5 square. Who is waiting out? N minus 1. So everyone has got their own individuality, except for them. We'll have to open them up and show the world. Go and see the world. 2 raised to n. What about this? So this will become 3 raised to m plus 1. Why, sir? ab raised to m can be written as a raised to m into b raised to m. So that matter, this is going to be 2 raised to m plus 1. What about this? So 5 raised to m minus n multiply by 2 raised to m minus n multiply by 3 raised to m plus n minus 2 multiply by 5 raised to m plus n minus 2. Okay guys, then what? 2 raised to 2m multiply by 3 raised to 2m plus n multiply by 5 raised to 10, sorry, not 10, 2m minus 2. So now do you know very well what we are supposed to do? All 2 together, all 3 together, 2 raised to n plus m plus 1. But I cannot add this because this is 2 and this is 3. I am adding this m plus 1. 2 raised to n. Again 2 raised to m plus 1. Then check where is 2. So here. Plus m minus n. Anywhere else? Nowhere else. Down, down, sir, down. There is 2m. Minus 2m. Perfect. Into. Let's start. Begin with 3. 3 raised to m plus 1. Anywhere 3, 3, 3, 3. So 3 here. Plus n minus 2. Anywhere 3, 3, 3, 3, 3. So here. So you'll have to subtract. Minus 2n minus n. Absolutely perfect. So 2 is done with, 3 is done with. Let's see for 5. 5 raised to 5 here. So you can say m minus n, 5 here. Plus n minus 2, 5 here. So this will get subtracted, minus 2m. And because this is already minus 2, so it's going to become plus 2. Now let us see. If you notice, m plus n, 2m. 2m minus 2m, m is gone. Minus n and plus n gone. So 2 raised to 1. So 2 raised to 1. Multiply by. Check out for this. M plus n, 2m minus 2m plus n minus n. What remains? So 1 minus 2. Check it out. 1 minus 2. That is 3 raised to minus 1. Multiply by. M plus n minus 2m. All out. Plus n minus n. Out. Minus 2 plus 2. Out. That's going to be 5 raised to 0. My dear friends, we all know here 2. This can be written as 1 upon 3. And anything raised to 0 is 1. So 2 upon 3 would be the answer to this question. Though it looks big, but it's a simple property of laws of indices that we have done so many times. Alright, let's move on to the next question. These two questions are the most important questions and they are very much logical also. Trust me, you will enjoy doing that. Have a look at it. This, as we know, a raised to minus 1 can be written as 1 upon a. Same way this can be written as 1 upon a plus 1 upon b. Let me write LHS because we have to prove eventually this total is going to be equal to this one. Alright, plus a raised to minus 1 can be written as 1 upon a. 1 upon a minus 1 upon b. So guys, LHS equals to 1 upon a. If you take the LCM, you get b plus a upon ab. That's b into 1 plus a into 1 upon a into b, ab. Plus 1 upon a. Same way we'll take the LCM over here also, b minus a upon ab. So my dear friends, from here on, as we know that a upon b divided by c upon d would mean a upon b divided by c upon d. which means A upon B multiplied by D upon C. So eventually जो सबसे ऊपर है और जो सबसे नीचे है चार टर्म्स में वो दोनों हमेशा साथ में कोलैबोरेट करेंगे and B and C will always stay together. So here also if I do so, my AB into 1 would be the numerator and this 2 is going to form the denominator, which would be B plus A. Here same thing, 1 into AB, that will be AB. What remains? Sir, A, B minus A. Anything to be cancelled? A cancels, A cancels. What remains? So B upon B plus A plus B upon B minus A. From here on, can I see? Take the LCM B minus A plus B plus A, the whole upon B plus A, B minus A is identity B square minus A square. What does that mean? So it will result in B square minus AB plus B square plus AB, the whole upon B square minus A square. If you notice, AB will get cancelled, B square plus B square, that would be 2B square. B square minus A square. So guys, this is how we got our solution. LHS equals to RHS. Pretty simple, simply following the rules of algebraic expression as well as the rules of indices. Very common question, very interesting question, teacher's favorite question. A plus B plus C, the whole upon. This can be written as 1 upon A multiplied by 1 upon B plus this would be 1 upon B multiplied by 1 upon C plus this would be 1 upon C multiplied by 1 upon A. So my dear friends, A plus B plus C, the whole upon 1 upon AB plus 1 upon BC plus 1 upon AC. Now in this situation, if you see numerator will remain as it is, let us consolidate the denominator by adding them. When you see there are fractions, if you add them, you have to take the LCM. Now the LCM would be A, B and C would be the LCM. What is missing over here? Sir, C. What is missing? A. And what is missing? B. Perfect. So C plus A plus B. So eventually what you get? Sir, A plus B plus C upon A plus B plus C multiplied by A, B, C. Truly perfect. This gets cancelled. You are left with ABC, which is nothing but RHS. With this, my dear friends, your question gets solved. One more question is left. That is question number, I guess, question number 10 and 11. Let me do 10 and 11 for you. Alright. Guys, this question is very simple and it is similar to the question which is there in exercise 7B, question number 14, 4th or maybe 5th question. It is identical, same. Fine, we are doing it. It's a very important question. 3 multiplied by this will give you 3 into 2 raised to x plus 3 into 1, that's 3. This is a complex, kindly divided into simpler form. So 2 raised to x into 2 raised to 2. As we know, a raised to m plus n can be written as a raised to m into a raised to n. So that's how we have simplified. Plus 5 is equal to 0. Now from here on, the only complex thing which we cannot find is 2 raised to x. So let me say, let 2 raised to x equals to a. So a will look like a normal number. 3 into a plus 3 minus 3 into 4 plus 5 equals to 0. अब ये आपको इक्वेशन काफी सिंपल लगेगा. 3 into a is 3a plus 3 minus 3 into 4, that is minus. Now if you notice, plus 3, it was 2 raised to x and 2 raised to x is a. So I should have written a over here, not 3. So it's going to be 4a plus 5 equals to 0. 3a minus 4a is a minus a plus 3 plus 8 equals to 0. minus a equals to minus 8, therefore a equals to 8. Since the value of a is obtained but we have to find the value of x, so we will resubstitute. So resubstitute 2 raised to x equals to 8. 2 raised to x equals to 8. 2 raised to x equals to 2 raised to 3. If you note this, bases are same, reason to smile. So therefore, x equals to 3. Yes, such a simple super solution. Here, my dear friend, we have to find the value of this. So what we will do is, let us find out what exactly this transpires into. Mn minus n plus 1. So we are interested in finding out the value of mn minus m plus 1. We'll wait for a moment and see what exactly we will get a picture from here. Solution. This can be written as a raised to mn, which is nothing but a raised to m plus n. Since the bases are same, so can we say mn will be equal to m plus n. So if you bring them over here, mn minus m minus n is going to be 0. So we have the value of mn minus m minus n equals to 0. What we have to find? To find the value of mn minus n minus m minus n plus 1. What is the value of mn minus m minus n? So it's 0. So 0 plus 1, final answer 1. Though at the face of it looked or appeared to us as if the question is difficult, but it requires courage and confidence to venture into this kind of questions and kill them by using the properties and the principles of indices. My dear friends, I'm sure you guys have enjoyed the class, enjoyed the lecture. Please do give your feedback in the comment section so that it can help others as well as us to help you better. Thank you so much for watching.